Hi everyone. Today let's look at bearing and distances. And what we'll be doing basically in this video is to solve some past questions on bearing and distances. We know you've been doing it for some time, but just to revise with us. Yeah, okay. Now to start with, let's go straight to example one. And in our example one, we have a question that says, y is 60 kilometer from x on bearing 135 degree, and z is 80 kilometer from x on bearing 225 degree. So we have to find the distance of z from y and bearing of z from y. Now, in order to do this, to solve any bearing question, you must first draw your diagram, except the diagram is given already. If the diagram is not given, definitely you are going to draw your diagram to really understand how your question will look like. Okay, now, and to do that, let's quickly look at what we have here. Okay, now this is the diagram for the question. We have y 60 kilometer from x on bearing 135 degree. So when we are bearing 135 degree, what we are meant to do is that we are to read from the north of the second mentioned point. They said that y from x, that is x is the reference point for that particular bearing. So we are to read on x from the north of x until we get to the line connecting x and y. So this is what we did in this video. So from here to here, we consider it to be equal to 135. Here to here, we consider it to be 135 degree. And if that is 135 degree, the remaining part here will be equal to 45 because angle on a straight line equal to 180. So that is why this point equal to 45. And the second statement says the bearing of point Z, the bearing of point Z from X is 225. Okay, and we still go back to X because I said from X simply means we have to read from the north of X until we get to the line connecting Z and X. So, and that is what we did here by reading from here to this place, and this represents 225. And if this place is 225, it means this angle also, the part here will be equal to 45. How do we arrive at that? We subtracted 180 from 225, and this part is 45, and that is what makes the whole angle here to be equal to 90 degree. And as we can see from the diagram, we made the line of 60 kilometer to be a bit less than uh, 80 kilometer. That is 80 kilometer must be longer than 60 kilometer. Always take that into consideration in your calculation of bearing so that you have a perfect diagram. Okay, another thing we did here is that if this angle is 45, this angle will also be equal to 45. How do we arrive at that? They are alternate angles, so this and this are equal. That is, alternate angles are equal. That is how we arrive at that. Now let's go to solution to this. The first thing we have to find is a distance between Z and Y. Okay, how do we do that? Let's move on to the solution here. Now to find the distance between Z and Y, since this angle here, equal to 90 degree, we can easily use a Pythagoras theorem to find the value of this side. Okay, and that is what we did here using Pythagoras theorem. We substituted all the values in the diagram into the equation. Remember Pythagoras theorem. If A is the hypotenuse, hypotenuse square will be equal to adjacent square plus opposite square, or whatever the case may be. So that is the same thing that we did here. And our ZY is considered to be the hypotenuse there. And substituting the values of other sides into the equation, we have our ZY to be equal to 100 kilometer. Okay, alpha set y to be equal to 100 kilometer. Now the second part of the question asks us to calculate, to find the bearing of Z from Y. To find the bearing of Z from Y, let me show you how you do that. Let's go back to the diagram. To find the bearing of Z from Y, now what you do is that you go to the Y because Y is mentioned later. Z from Y. So you go to Y, you read from the north of the Y until you get to the line connecting Y and Z. So the entire angle represented with this blue line is the bearing of Z from Y. And how do we do that? To do this, we need to find this angle. And by the time we know this angle, by the time we know this angle, if we want to know the bearing of Z from Y, we need to add this angle here plus this 45 and subtract the total from 360, and that will give us the bearing of Z from Y. So let's find angle theta here. Okay, now using sine rule, if you use sine rule, we can actually find that angle. And what is sine rule? When you have a triangle ABC, you will have done this already. You have triangle ABC, and this part is represented with small letters of the angle. So what sine rule says is that the side over the angle facing the side equal to another side over the angle facing that side equal to another side over the sine of angle facing the side. So you can equate any two. You can equate any two to each other. That is what sine rule is talking about. Okay, now using sine rule, now from that diagram we have 80 divided by the sine of y, which is angle facing 80, equal to 100 divided by sine of 90, which is angle facing the line 100. That is the hypotenuse of the diagram. So making sine y the subject of the formula, definitely we are going to have this multiplying sine 90, because what we have basically here is 80 over sine y equal to 100 over sine 90. So if you cross multiply, you can make sine y the subject of the formula, and that is what we did here. And our sine y become 80 multiplied by sine 90. 80 multiplied by sine 90 divided by 100, and that is what is here. Okay, using this method, we discovered our sine y equal to 0.8, and to find our y, we need to look for sine inverse of 0.8. And how to do that on your calculator, just press shift sine, now type 0.8, and it will give you this value here. So it means the angle theta in that diagram equals to 53.1. Now to find the bearing of Z from Y, we have to add the 45 in the diagram to 53.1, and we subtract it from 360, and that gives us the bearing of Z from Y to be equal to 261.9 degree, or you can as well write it as 262, which is approximated value of the bearing of Z from Y. Okay, let's move away from this. Let's go to the second question. In this second question, we have we have to quickly correct something here. The question is the bearing of Q from P, not bearing of P from Q. The question says the bearing of Q from P is 150 degree, and the bearing of P from R is 15 degree. If the Q and R are 24 kilometer and 32 kilometer respectively from P, we have to represent this information in a diagram. That's the first part of the question. Roman figure 2, we have to calculate the distance between Q and R to 2 places of decimal, and Roman figure 3, we have to find the bearing of R from Q. Okay, how do we do that? Let's quickly check this in our diagram. Okay, the first statement in the question says the bearing of Q from P. Q from P. If it is Q from P, it means we are going to P, which is second mentioned point. Q from P. So we go to P, the knot of P, and we read 150 according to the question. So our 150 is here. 150 is 90 plus 60. So 150 is here, and the remaining portion to get to 180 is 30. So that makes this angle to be equal to 30. And PQ according to the question is 24 kilometer. Okay. Now the second part of the question mentions that the bearing of P from R. So if it is bearing of P from R, we go to R and we read from the knot of R. The bearing of P from R is 15 degrees. So we read 15 degrees from knot of R to the line joining R and P together. And PR according to the question is 32 kilometer. So this place is 15 degree, and that is what makes this place to be equal to 15 degree. That is a alternate angle. They are always equal. That is why this place is equal to this place, and they're equal to 15. Okay, summing this and this together, we have 45. The whole of this angle equal to 45 degree. Okay, now first thing we have to calculate in that question is we have to find the distance RQ to two places of decimal. Okay, let's see how we do this. Here we have angle 45, so definitely we are going to use cosine rule. And for cosine rule, when you have a triangle like this, we can say this side, the square of this side, equal to the square of this side plus the square of this side, minus 2 multiplied by this side and this side, cos the angle facing the side we are considering. So let's see the equation how it is written. Okay, you can see the square of side RQ, because the square of this side equal to the square of this side plus the square of this side, minus 2 multiplied by PR times PQ cos angle P, which is 45. Okay, now we substituted all the values into the equation. That is what we have here, and that makes our RQ squared to be equal to 1600 minus 1086.1. Please don't make this mistake when you are dealing with equations like this. Do this separately. Even in your equation, you can put it in brackets. Do it separately and do this part separately. So this part will give us 1600, while this part will give us 1086.1. Okay, subtracting 1086.1 from 1600, we have 513 as the value of our RQ square. Now to get the value of our RQ, we have to find the root of 513, and that is what gives us 22.7 kilometer. And to two places of decimal, we have to write it as 22.70 kilometer. And the second part asks us to find the bearing of okay, let me check again, the bearing of what from what. The second part of the question asks us to sorry, the third part. The first part is the diagram, and we've been able to do that. Second part is the distance between Q and R, and the third part asks us to find the bearing of R from Q. Bearing of R from Q. Now from this diagram, bearing of R from Q, if we are to find bearing of R from Q, remember we'll go to Q and we'll read from the knot of Q until we get to the line connecting Q and R. So this blue color represents the bearing of the angle that this blue color indicates represents the bearing of R from Q. Okay, now and to find this, we need to know the value of this angle. Let's call it angle theta. By knowing the value of this angle, we add it to 30 degree and we subtract their sum from 360, and that will give us the bearing of R from Q. Okay, let's go back to the solution, and here we use sine rule. And what we did basically, we've explained sine rule in our first equation. We have 32 over sine q equals to 22.7 over sine 45 degree. And we cross multiply to make sine q the subject of the formula, and we have 32 multiplied by sine 45 over 22.7, and with that we are able to get the value of our sine q to be equal to 0.9968, and we find the value of our q by getting the sine inverse of 0.9968. And to get the sine inverse, you press shift sign on your calculator, and that gives us the value of angle q as 85.4 degree. And that's adding that to 30 degree and subtracting it from 360 degree, we have a 245 degree as the value of a bearing of R from Q. Okay, with that we come to the end of the two examples that we have in this video. And please, if you have any question on whatever we've done in this video, or probably you have some other questions, the comment section will be open for discussion. Just drop your question and it will be discussed. And just before I go, please, if you are yet to subscribe to this channel, please do subscribe to the channel. And if any of our video has added any value to your knowledge, please always click on like and drop your comments, and also click on the notification bell so that when we release a subsequent video you will be notified. And I would like to introduce this physics practical book to us. The name is Refine Physics Practical Book. It's one of the best you can see around now. The reason why it's one of the best is because this book handles everything that has to do with practicals for our school candidates, that is the candidate preparing for WAEC and NECO examination, and also for our private candidates, that is the candidate preparing for our GCE and NECO GCE. And in addition to that, we have practice exercises for preparation for Cambridge IGC SE as well. So we have so many exercises here, including alternative to practical to physics. And if you are in need of this book, you can contact any of the numbers shown on the screen or the email address, or if you choose to go for soft copy of the book, you can get that on Amazon. And before we go, some of our other services are online tutorial in physics and mathematics for exams such as WAEC, NECO, UTME, Cambridge IGCSE. And if you're interested in any of these online tutorial through virtual means like WhatsApp, Zoom, and Google Meet, you can contact the number on the screen, and we'll discuss. And for all the video we've been releasing, we've compiled a very good note for all this video. If you're interested in the note, you can as well contact the number on the screen, and we'll have a discussion. And just before I go again, I would like to repeat this. If you're yet to subscribe to our channel, please do. Thank you, and God bless you.